Our next module will actually be creating the connector and putting it on the interface. By an interface, I mean a splitter, a tap, a ground block, an amplifier, something in the home or on the street. Now, a couple things we should go over. We've talked about how to prep the cable, how to make sure you put the connector on the cable correctly. Actually, one of the more important points is mating it up to the interface to make that 75 ohm connection. First of all, look at your mating interface that you're going into. I really recommend that you inspect it, visually look at it, see if the interface here where the connector is going to ground itself out is damaged at all. If it's gouged up, if it's nicked, anything's wrong with it, then it doesn't create a good grounding effect and can affect the performance of your connector. If you notice that, at that point, you really should consider starting to change that piece of equipment out. Again, you've made the good connector, why put it on a bad piece of equipment that's been here and been mishandled in the past by previous technicians? Because a big thing we're going to talk about here is how to actually, once the connector is prepared, once it's put on, how to tighten it down properly and what it really takes. Again, we discussed that drop connectors are probably well over 70% of your service calls on a daily basis in your system. And what is the cause of that? Well, we know that moisture migration into it, letting oxygen gets in there, things oxidize, cause different problems, can affect signal passage, but also the tightening down of the connector. Now, I mentioned earlier that we had the quick prep cable. It takes a step out of preparation as an innovation. Another thing that has come out of a couple innovations on drop connectors is we would talk about is what we call our quick shield connector, or a continuity style connector. And what that allows you to do is it removes a lot of what we would say would be the tiling or packet loss in a digital environment where a connector gets loose. And as it moves around, cable fluctuates in temperature. If it's outside, wind moves it, you break the ground plane, you see pixelation on your picture or packet loss, phone loss, things like that. Times Fiber has developed what we call the Quick Shield connector that takes care of that. Another big issue with connectors is weatherproofing a connector. Again, another Times Fiber feature is our Quick Connect connector with the integral weather seal inside of it. And what that weather seal does is when you're tightening the connector down, the O-ring that's inside the connector does not affect the mating interface and actually goes around the chamfer of your mating interface, and as you tighten it down, creates a weather seal. And while we don't recommend it, but even in a loosened state, it allows that connector with the quick shield to stop the ground plane issues and any moisture migration come in. Now, why is that important? Over the years, most technicians feel that when they tighten down a connector, tighter is better. Tighter isn't better, because when you over tighten a connector, you're now putting these two mating interfaces together under heavy stress, and you can be damaging those interfaces. And again, if you put scores and marks in that, you nicked it, whatever like that, it creates a place for a reflection and causes signal problems. With this connector, and done properly, it takes care of that issue. There are other ways to do it, external weather seals that companies that would use, and the issue with doing that is you have to put this thing on, and it's only going to be used outside, and you're fighting to get the connector started, lined up, and tightening it down. Now, while that works great, if the connector's loose, you may have stopped moisture from getting into it, you still have ground plane issues. So it doesn't solve all your problems. And in a lot of places you might be using two connectors, an indoor and an outdoor connector. If you use the solution that we offer, it's one connector. So you don't have to worry about different inventory in your warehouse, or I'm up on a pole, oh my gosh, I forgot my outside connector. I have an inside one here. I don't feel like going back down the ladder, climbing down on my hooks. This baby's going on. Nobody will know the difference. So you don't want to do that. Again, this is all about putting a connector on properly to make it last and make the reduction in service calls and allow your people to do other things. We talked about examining the interface, making sure it's proper, that it's not damaged, because a lot of times people go out and have a damaged interface and they'll blame it on a drop connector. Well, it wasn't the drop connector, it was the existing equipment in the home that was already there and over-torqued in the previous iterations of people being there. So, what do you do when you tighten the connector down? The average person, you notice I'm still wearing the nitro gloves to give myself some gripping force. The average person with a bare connector, and this can be homeowner, it can be a technician, is going to be able to torque that connector barehanded from 1.5 to about 3.5 inch-pounds of torque. That isn't sufficient. A connector really needs to go above 5 inch-pounds of torque. At that point, it no longer can come loose. You know, a lot of people will say, well, connectors vibrate loose, they're out there in a pole, semis go by, things like that. Tests have proven by numerous companies that anything torqued over more than 5 inch-pounds of torque does not vibrate loose. So that's the minimum you want to be. Now, one device to use, especially in a home, self-install kit, jumpers going out for customers doing their own work, might be a connector with what we call, it's this connector right here with a quick torque device on it. It's an overmolded plastic sleeve, and it easily allows barehanded to get about 7 to 8 inch-pounds of torque for the average person, because a lot of your service calls are caused by customers moving equipment, doing their own installs, and not tightening things down. Another thing is when you're on the back of CPE or customer premise equipment, people's TV sets, Blu-ray players, DVD players, you don't want to tighten down with a wrench or anything else in the back of that, because the way that F81 comes through the back of the equipment, it's usually only held there to keep from rotating by a plastic tab. And if you start putting 14, 15 pounds or more of inch-pounds of torque on there, you're going to snap that little barrel free and it'll rotate. And any technician that's been around for any long period of time has probably done that and run into it, and somebody's repaired somebody's TV, which is not the nicest thing to have to do, and it upsets the customers. So again, back to what is the proper torquing. As I said, you want to be a minimum of 5. Really, the ideal is going to be 10 to 12 inch-pounds of torque. When you get to that point, we know you've made a good connection, you're not damaging customer premise equipment, the connector is tightened sufficiently, it won't come loose, and if you tie that in with the quick shield and the quick torque features offered in this one, you've got a great interface. So let's make the interface up. Again, we don't have to weatherproof this. This is outside. Times Fiber connector has the internal weather seal. So we've made sure that it's good and clean. And another, I'll just throw out there as a little safety thing. If you're dealing on the outside of the house, you've worked on there, you have a splitter, a bonding block or something, before you make your connection up. Now these gloves will come in handy if you're using them for this, but most people don't realize that there is always a current load on a drop going back to the street. The unbalanced current load from your meter panel can vary during the day, but the average is you're going to see probably 0.5 amp up to 2 amps of current on that drop. If you don't really believe that, use a clamp-on ammeter and measure every time you go up to a drop. Safest piece of equipment to use. Foreign voltage detectors that most people carry are great, but they don't measure current, and they only kick off at about 50 volts. You don't have to have a lot of voltage, but you can have a lot of current. Voltage doesn't take you out, current does. So do that. So what I recommend people do is one-handed, if you're hooking something up, going to the drop to the outside, hold the cable by the jacket. Best thing to have the gloves on. It's the best thing to do. Now, I'm not going to pick that up because you'll say, see, he's holding both. Is just flick the connector against that. If you see a spark or large spark, hear something arcing, then be very cautious. Again, you know, your company will set standards what they allow you to deal with, but clamp-on ammeter will tell you if you're running, if you've got 15 or 20 amps of current, then there's probably a bad neutral in the house and you're causing a problem. And most of you have probably run into that before when you're outside in a house and you stand there at a ground block of the splitter, disconnecting something to take a measurement from the street, and you, unfortunately, most people, one hand on the ground block of the splitter, one hand on the connector. Well, if there's a bad neutral or any power there and you snap that apart, you've now become the circuit. So I'm just telling you, don't do that. Once you get loose, one hand the connector off, keep your left hand out of the way, or your right hand, whatever is your dominant hand, use that. Only touch things with one hand. So we're back to the point. Again, for demonstration, I'll make it easier. I'm going to hook this thing up. I will tighten it up by spinning the nut on the connector. All right. So you say, where am I in the house and where am I going to tighten this? Where in the drop? Am I outside? Now, standard is, you know, a lot of people use a torque wrench. Different manufacturers make them. There's different standards, what your company wants for torque strength. When you're inside the house, you want to have 10 to 12 inch-pounds of torque. Roughly 12 is the best. If you can be there, then you've made a good connection. So I bring it to you. If 12 inch-pounds of torque is good in the house, Why would it be any different out on the street? It's not going to vibrate loose. Why would you over tighten? So if you tighten something to 12 inch-pounds of torque and it works fine in this situation, it should work fine there. You don't have to go tighter is better. Get the biggest, short 7/16 inch. You can get them this long and put down as much strength as you want. You may think that if I get it tighter, I won't get any moisture in it without any thread protection. The threads used in the cable system are machine threads, not pipe threads. They don't stop moisture. Doesn't matter how tight you make them. Okay? And again, your connectors are a malleable brass. At some point, you're going to start galling threads and strip things. And then you may think you have it tight. You want to use the torque recommendation of your company. Again, I recommend around 12 inch-pounds of torque. Again, if it's good enough behind the set, all through the house, it's going to work just fine outside. Another reason we recommend that, and I recommend that, is at that setting you aren't damaging the mating interfaces. If I sit there and doesn't matter whose torque tool I use, and I say, okay, I'm going to go to 30 inch-pounds of torque. Now this tool is 30 inch-pounds of torque when it breaks. And there's the break. I just made it. But do most people stop at that point? They don't realize, and they aren't slowly going up to that point to hit the break point. What they do is they put it on there and they go like that. And they just did it. Well, I just added another quarter turn once I hit the break point on this. And because the mating interfaces are joining up metal to metal at that point, that quarter turn can easily take me to 60 to 80 inch-pounds of torque. We've tested that numerous times, different tools, so it's based on how quickly do you stop it and what do you bring it at. So you have to be very careful. And that used to be the standard, especially inside. Finger tighten, quarter turn, maybe an eighth turn. Again, eighth turn can be 30 or 40 inch-pounds of torque. We said earlier that you go above 14 or 15, you more than likely broke the F81 free. So slow down, take your time to connect these, inspect the interface. Use the proper tool. There's a variety of different ones you can do it. These little tools are great. They have a thinner side to work on the back side if you're reaching up behind a TV set. And what they'll do is, if you torque them up too much, at about 12 inch-pounds, they'll start slipping around, they'll expand out. They're going to spring back in place for the next time, but they'll work. You can use one of these little wrenches, but if you over-torque that, you'll actually break the little wrench. So I recommend this or a proper setting of a torque wrench before you go on. Hopefully we've covered a lot of issues here and opened up your eyes to a few things, and are just changing the way you look at how the connectors interface and made up. Don't take for granted that it's always a connector that's bad. Review everything else in the system and how it's interfaced, because there's a very good chance that is the issue. Thank you very much. Have a productive day.